Okay, students, we're now going to go over Mod 1, Topic 1, Lesson 4. It's on page 45 in your book. Okay, so here we have, as it says, review Pythagorean theorem, 8th grade geometry. Okay, a squared plus b squared equals c squared, you learned. Remember, a, b, and c are lowercase because they're sides, names of sides, and they are always lowercase. Capital letters go with angles. Okay, and c is always the hypotenuse. Notice the hypotenuse is always opposite the 90-degree angle. It's always the longest side. So here we have 4 squared plus 10 squared equals c squared. 16 plus 100 equals c squared. By the way, you should pause the video and work these three out on your own and then hit play and see if you got them right. So I have 116 equals c squared. Take the square root. That's how you go from c squared down to c. Just take the square root. Even though there's two answers, we don't deal with a negative answer because normally plus or minus because a side length cannot be negative. So we only deal with the positive answer. So I need to reduce that radical. You practice reducing radicals in your warm-ups. I'm looking for a perfect square that goes into that. 4 goes into that. The reason I know 4 goes into it because 4 goes in the last two digits evenly. 4 goes into 16 evenly, so I know 4 will go into that. So 4 goes into 11 2 times. That's 3 left over, 36. 4 goes into 36 9 times. Okay, should have a square root times a square root. One of them is being a perfect square. And which one of these simplifies? Only the square root of 4 down to 2. So it's 2 root 29. It's my exact answer. That's exact. And then I go back and read the directions to see if they want exact. Nope, round it to nearest tenth. So now we just go back up to here and square 116 and put that in your calculator. Okay, and type that in. 116 square root, I get 10.8 to the nearest tenth. So approximately 10.8. Okay, here we have 5, 5, and C. Well, since we've already done 30, 60, 90s, and 45, 45, 90s are special right triangles, I should automatically know that's an isosceles right triangle. So it's a 45, 45, 90. And then I should know the hypotenuse is root 2 times longer than the legs. So it's 5 root 2 for the exact answer. Of course, now I need to go ahead and type in the calculator. I have 5 times 2 square root equals 7.1 to the nearest tenth. So approximately 7.1. All right. And here we have 15, 20. Well, I should see that there's a GCF of 5 in there. If I divide each by 5, I get 3, 4, and that should recognize I have a 3, 4, 5 Pythagorean triple. So remember, I multiplied by 5 on each of the sides, go from 3 to 15 is 5, and 4 times 5 is 20, so 5 times 5 is 25. Okay, so that's using Pythagorean triples. Huge advantage of knowing that. It says that's, I don't, notice this, if necessary, I don't need to because it comes out to a nice number already, a whole number, natural number. All right, here we go with the lesson now. Congruent means to have the same size and shape. There's no reason to say measure because that deals with the shape. Okay. A trapezoid has at least one pair of parallel sides. We know that definition called Quadratic-Harky theorem that you just got done doing. And an isosceles triangle has at least 2 congruent sides. So again, that's review vocabulary. Okay, that we've already had. Sorry. We have not had that here. This is the beginning of the year. You should have had it last year when you talked about congruence. Okay, but congruent, same size and shape. Same size and shape. That's what you should have it memorized as. Okay, and trapezoid has at least one pair of parallel sides. You're going to get into this later with the Quadratic-Harky theorem in Mod 2, Topic 3. Okay, that's the definition of trapezoid. An isosceles triangle has at least, that's a key word, at least, not just 2 sides. Now, granted, almost every time it's 2 sides, but at least that means it includes 3 sides. So an equilateral triangle is also, by definition, isosceles. Okay, adjacent just means next to, the easiest way. Adjacent sides are sides that share a vertex. Okay, just think adjacent means next to. Okay. Determine whether each statement is always true, sometimes true, and never true. Well, if you have the corollary hierarchy theorem, we'd be able to easily see this. So this is knowing it if you know your definitions of these from middle school. A rectangle is a parallelogram, always is true. A rhombus is square. Sometimes, pretty much it never is, but it could be. Okay, a scaling triangle, scaling means all different side lengths. Is a right triangle? No. Well, it could be because you could have a 90 and then like this. Okay, it's going to have 3 different side lengths. It can have one as right angle. So yes, it's sometimes. A parallelogram is a trapezoid, always. Okay, because definition of trapezoid, at least one pair of parallel sides, and parallelogram is 2 pairs of parallel sides, so it fits its definition. A right triangle is an equilateral triangle. Okay, never, because an equilateral triangle, all the angles have to be 60 degrees, because all the angles are congruent. There's our congruent symbol, the arc. And 180 divided by 3 is 60, so they're always 60, and equilateral, and a right triangle has a 90-degree angle with it, which you can't have with an equilateral. Calculating distance on the coordinate plane. Classify the quadrilateral. Okay. So we have this. We count up all 4 sides are right angles, so that's the definition of a rectangle. And now the only difference is, are all 4 sides equal, which they are, which now makes it a square. Okay, square is 4 right angles and congruent sides. Okay, here's review: perpendicular 90 degrees, right angle also. Perpendicular is negative reciprocal. Remember, all vertical and horizontal lines are perpendicular to each other. We learned already. Okay, so here we have what this is it might look like a rhombus to begin with, but I check using Pythagorean theorem, and all the sides come out to be 5. They're all 3, 4, 5 Pythagorean triples when I do my right triangle. Okay, so that now fits the definition of rhombus and square. All 4 sides is a rhombus and a square. Now, if they're all 4 right angles, then it becomes a square. So now I have to check to see if the slopes are negative reciprocals. So that slope is 4/3. This slope right here is negative 3/4. Remember, it's changing y over changing x. So negative 3/4. Are those negative reciprocals? Yes, they are. It's a negative sign there. Negative 3/4. So yes, they are. So that's perpendicular, and I can go with that all the way around. They're all 90 degrees. All 4 sides congruent, therefore it's also a square. By the way, right here are Pythagorean triples. That would have helped save instead of having to use Pythagorean theorem. If I use my Pythagorean triples, 3, 4, 5 is the most common one. That's what we had right here. You have 5, 12, 13. Notice the longest side is always the last one here, so that's always the hypotenuse. The longest side is always the hypotenuse. 7, 24, 25, 8, 15, 17, and 9, 40, 41, and any of their multiples. Those are called Pythagorean triples, which I have right there. Okay. The distance formula is another name. You can rewrite the Pythagorean theorem as the distance formula. So you need to know, whenever you say Pythagorean theorem and I ask you what's another name for Pythagorean theorem, you tell me distance formula. The distance formula itself is right here. Okay, and that's a lot more to memorize than just straight easily the Pythagorean theorem. A squared plus b squared equals c squared. Okay. So where this came from then is I started with a squared plus b squared equals c squared. I need to solve this c. It's the same as the d here. So notice this is d to the first. So I need to take the square root of both sides. Now I have c equals the square root of a squared plus b squared. Well, this distance down here is the same as our A distance. If I subtract the X coordinates, that's like A. I subtract the Y coordinates for this length right here, that's like my B. And of course, hypotenuse is then like C. So I'd have my A squared plus B squared equals C squared and take the square root. Okay? And so here we're using it with Pythagorean theorem, and here it's just, if I just take the points and I don't draw out the triangle at all, and to me, it's easier to plot the points, draw your right triangle, and do Pythagorean theorem because you can count the legs distance, the horizontal and vertical distance, and not screw up. Whereas here, you're subtracting two integers and then squaring it, and some people can't subtract the integers correctly and blow it. Or when they square it, they leave a negative on whenever you square a number, it must be positive. So you've heard the phrase, a picture's worth 1,000 words. It's much easier to use the picture. Okay. Here we have the word symbol for similar, and here this is approximate. Two of the same one for similar is approximate. That's like if you're rounding nearest tenth, hundredth, etc. Okay, so use the distance formula to calculate the distance between each pair of points. Round your answer to the nearest tenth if necessary, as if it doesn't constitute a natural number to begin with. Okay, so it's the square root of, and all you're doing is, it doesn't matter which one you do, you're going to do both of them. Change in the y's, so 7 minus 5, or 2, I mean, that's that one, squared, plus the change in the x, 3 minus 1 squared. Okay, it's just that's a simple way of saying distance formula, the square root of changing x squared plus changing y squared. So I have 5 squared is 25 plus 2 squared is 4 is 29 is the exact answer. So you see the word exact, but they want the nearest tenth, so now you put that in the calculator, 29 square root, and you get 5.4. So I have that right there. Here, you can pause the video if you want and do it on your own with this here, same idea. Okay, the key is you go in the same direction. So there I went left minus right. I could go right minus left. And the other key is you match up the x coordinate with the x coordinate and y with y. It doesn't matter which direction you go. Okay. So here 4 minus a minus 8 makes it 4 plus 8. And here negative 6 minus 2 is negative 8 squared. Okay, so you got 12 squared and negative 8 squared. You get 144 plus 64 is 208. That's the exact answer, and they went the nearest tenth, so just plug it in the calculator and you get 14.4. There's another one with the work. If you need for more practice, you could pause the video and work that out and see if you got it right. Okay, classifying the triangles in the coordinate plane. Classify means they identify the type of triangle. So, you have isosceles, equilateral, or scalene. Scalene, no sides. 0 sides congruent. Isosceles, there's at least 2 sides congruent. And equilateral, three sides congruent. Okay, remember Pythagorean theorem equals the distance formula. All right, so let's consider triangle ABC here. I'll go ahead and erase this and start from scratch so you can see it. So I'm drawing a right triangle for each one. Let's change the color so you can see it easier. And that's -5, so I went up 1 and I went right 2. So I have 2 squared plus 1 squared is 5. Square root of 5. So that's a square root of 5. Let's change the color. Square root of 5 right there. So that's that distance. Here we can just count from -9 to -4 is 5 for that distance. And now I do this one, right triangle there, at 1, 2, 3, 4, and 2 there. So it's 16 plus 4 is 20. So square root of 20. So notice they're all 3 different lengths. Square root of 5, square root of 20, and 5. Those are all different. So it's a scalene. Now the question is whether it's just scalene or is it also a right triangle? Well, the question is therefore, what are these slopes? Right here, remember I had 1 and 2. Oops, 1. So the slope there is 1/2. that slope is 1/2. And what is this slope right here to see? Because it looks like it's 90. Is it though? Change in y, we're going down 4 and right 2. So it's -4 over 2 is -2, or -2 over 1. Are those negative reciprocals? And the answer is yes. So therefore they are perpendicular. So that's why it's a scalene right triangle. Okay. So we got more specific. Here it says consider the triangle sides of ABC described as scalene, isosceles, or equilateral. So it was scalene. We got even more specific because we're calling it scalene right because it looked like writing us. So we want to check the slopes. The second part, now determine whether it's a right triangle. We just did that. So scalene and right. Okay, the converse of the Pythagorean theorem. Converse means you switch the if and the then. So the Pythagorean theorem says if you have a right triangle, then a squared plus b squared equals c squared. Remember, c is your hypotenuse, which is your longest side. So the converse of that is to switch it. So if a squared plus b squared equals c squared, then you have a right triangle. Okay, so converse switches the if and the then. So if a squared plus b squared equals c squared, then it is a right triangle. Okay, that's the converse. Converse means switch the if and the then. All right, now we're getting into types of triangles as well, whether it's a right triangle, acute, or obtuse. Okay, these are on the decals, as it says right there. You'll have one of these. And you think of it as like the Pythagorean theorem. You have a c squared blank to fill in whether it's equal to, greater than, or less than a squared plus b squared. C squared, c is always your longest side, no matter where it is. What kind of triangle that's the longest side. So notice, if it's equals it, it's a right triangle. We already know that from Pythagorean theorem. Okay, converse of the Pythagorean theorem, we just said it. Now, if c squared is less than a squared plus b squared, it's going to be acute. And if c squared is greater than a squared plus b squared, then it's going to be obtuse. Okay, so here are some examples for you to check here. We'll just go over this harder one right here. So first I have to identify that square root of 80 is 65 is the longest side. That's 8 point something, whereas you got 7 there and 4 there. So this has got to be my c. So c squared, square 65 squared. Remember, I square root. I just take it just takes off the radical. So 65 equals 4 squared plus 7 squared. 16 plus 49 equals 65. So that is a right triangle right there. Okay, and we did I did a there, and it came out to be greater, so that's obtuse up there. All right, let's see. They give you points this time for you to plot and then figure out whether it's scalene, isosceles, etc., and then whether it's acute, obtuse, or right. So you're doing both. Okay, so again, I'm going to plot the points, draw, or use a straight edge and connect them. And then I'm going to find the length of each side. If it's a horizontal or vertical one, like this one right here, I can just count it, and that's a total of 10. But if it's an oblique segment, I have to use the right triangle and do Pythagorean theorem. Well, here I have a 6 and an 8, and 6, 8, 10 Pythagorean triple, or I could have done 36 plus 64, a squared plus b squared equals c squared. 36 plus 64 equals 100, and the square root of 100 is 10. Okay, now over here I draw my right triangle, and I get a length of 2 and 6. So I square each one, because again, I'm trying to find the hypotenuse. So 4 plus 36 is 40, square root of 40, which then reduces down to 2 root 10. So I have a 2 root 10 length, a 10, and a 10. So if I have two 10s, I know that means it's an isosceles triangle. So I have an isosceles triangle is part of it. Okay, isosceles. And now, since the longest side is 10, I would have 10 squared equals, oops, not equals, 10 squared blank. The other two sides, 10 squared plus square root of 40 squared. Well, obviously that's less than. Okay, and so therefore it's an isosceles acute triangle. Okay, isosceles because it got two congruent sides, acute because the c squared is less than a squared plus b squared. I know that on the DCAS. Okay, so there's the work for that down there as well. just put it up there before. Okay. Next. How is known that a square has two pairs of parallel sides help determine the unknown location? We can use the slope is the easiest way to do it. So where's this unknown? Okay, so here, well, there's multiple ways. Parallel means it has to have the same slope. Okay, so if I see this slope right here, oops, so like this, 1, 2, 3, 4, down 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And right 10, that means I have to go down 4 here. 1, 2, 3, 4, right 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there's my point. So it's the same slope. They're parallel. Okay, remember parallel means same slope. And there's my missing point, 5, 3. That kind of question is actually on your test. Doing that. That's a test question, so know that. You can see on the DCAS as well. How does knowing that squares 4 right angles help determine the unknown location? Okay. Well, if I know that these are right angles, then whatever this slope is, I could do the negative reciprocal of it and go up that way. Okay, so since this slope is negative 4/10, or that means so negative 4/10, what's the negative reciprocal of that? 10/4. Okay, so we go up 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and right 4, 1, 2, 3, 4. And there we go right there. That will also take it to it. Okay, because perpendicular 90 degrees or right angle, perpendicular negative reciprocal. Okay, so we have those right there. Come on. Okay, classify a quadrilateral on the coordinate plane. What type of quadrilateral is it? So we got to plot the points first. Okay, and then we look at it and we see all 4 sides are 5, but that their slopes are not negative reciprocals. Remember, if the slopes are negative reciprocals, then they're 90 degrees. Negative 4/3 and positive 4/3 are not negative reciprocals. Those are just opposites. So it's not 90 degrees, so therefore it is a rhombus. Okay, 4 congruent sides and the opposite sides are parallel. That's a rhombus. Okay, if there are 4 right angles, then it'd be a square. Okay, again, we're choosing between trapezoid, rhombus, rectangle, square, or none. So we plot those right there. I have it like that. Hopefully, it looks like that these are parallel, which would make it, and there's only one set that's parallel. So that looks like a trapezoid. We could check it. 1, 2, 3, and right 1. 1, 2, 3, and right 1. Yes, slopes are 3. So those are parallel. So that makes it at least a trapezoid, and these aren't parallel. So I'm having a trapezoid. Now, if these distances are the same, if that leg is congruent to that leg, then it'll be an isosceles trapezoid. They didn't give us that option, so we could just stop right here and say it's a trapezoid. Well, let's go ahead and test to see if it is isosceles. Are those two congruent? So if I draw that right triangle, do that. 1, 2, 3, 4, 5, 6, 7, and 1. So this length would be square root of 50. 47 squared plus 1 squared is 50. Square root of 50. Here, what do we have here? 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. 25 plus 25 is 50. So it's square root of 50. So yes, those are congruent. So that technically is an isosceles trapezoid. They didn't ask for that, so we can just say it's a trapezoid, but technically it's an isosceles trapezoid, if you want to be more specific, because those two legs are congruent. Okay. Midpoint formula it finds the midpoint between 2 points, and that's the right here. So write that down for your formulas. That's the average of the x coordinates, comma, the average of the y coordinates. Okay. So use the midpoint formula to determine the midpoints of each side of the given figures. Okay. So all I do is take those points right there, x and y. So that's 0, 8, and this one is negative 8, 0. So Adam, 0 plus 8 is negative 8 divided by 2, comma 8 plus 0 is 8 divided by 2. So negative 4, comma 4. I could do the same thing with the other ones, and I get that one, and that one. Okay. This is square to begin with, and if you do that with squares, they just continue to be squares. Okay, I could do it again, and then I have it there, 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 and there. Connect that, and those would continue to be squares. Okay, and you could keep repeating that. That's a special thing with squares there. Okay. So here's the one where we say, how do we find out where it's going to be a parallelogram? Again, slope. So if I went like this, went down and to the left, how many did I go down? Went from 8 to 2, so that's down 6, and from 7 to 2, right 5. So that means I go down 6 and right 5. Again there, down 6 and right 5, so it's going to be parallel right there. So if I go down 6, this point 8 minus 6 is 2, and 13 minus 5 is 8. So it'll be an 8 comma 2 is where that point would be to make it a parallelogram. Okay, same slope, parallelograms, parallel sides. Okay, so you're gonna have a question like that on your test and possibly on the DCAS. All right, so that's the chapter right, or the top lesson right there. Here again, we have distance formula. Remember, that's the same thing as Pythagorean theorem.